Good evening and welcome. Good evening, Ugwu. Ugwu, are you there? Ogundeji. Ogundeji, are you there? Ogundeji, good evening.
Good evening, sir.
Can you hear me?
Yes, I can hear you clearly, sir.
Okay. Welcome.
You're welcome, sir.
We are going to start without just in the next 1 minute. Let's see if we can have more people available.
Okay, sir.
Mwigwe Grace. Okay, good evening, everyone, and welcome to Chem 102 Facilitation Week 5. We are not going to waste time any longer. Those who didn't join early will still have time to attend to their questions, so we can start immediately. Okay, so today, we are going to be continuing our discussion on alkanes. You know, last week we started alkanes, and today we want to continue with our discussion on alkane. We are going to be looking at preparation of alkanes and of course, cycloalkanes. Preparation of alkanes and cycloalkanes. So, like I mentioned last week, the major source of alkanes, whether acyclic or cycloalkanes, is petroleum and natural gas. If you remember our discussion on the sources of alkane, you will remember that we mentioned that the major source was petroleum and natural gas. So these are the major source of alkanes. However, there are a number of synthetic methods through which we can get alkane. And now the question is, since petroleum is a method of alkane, why do the answer is very simple. The from petroleum are not alkanes obtained from petroleum are not as pure as the alkanes. So depending on the application of the alkane, synthetic methods are still quite and of this synthetic method we are going to be looking at. Sorry, we had a network problem. So, as I was saying, that we have alkanes from alkene or alkyne, which is from hydrogenation of alkenes or unsaturated compounds. Then we also have alkanes from hydrolysis of alkyl halides, and then alkanes from decarboxylation of carboxylic acid. There are other ways of preparing alkanes. So let's just take a look. We have a scheme here, which is showing exactly what I was saying. Number one method of preparing alkane is from Wall's reaction. In Wall's reaction, what happens is that two molecules of alkyl halides react with two molecules of metallic sodium, and then they will give RR, which is alkane, and then two molecules of sodium halide. Then the next one is from Kolbe's electrolytic method. In this Kolbe's electrolytic method, what happens is that this is a carboxylic acid salt potassium salt of carboxylic acid, 2 molecules of potassium salts of carboxylic acid undergoing decarboxylation. Decarboxylation, that is removal of CO2. You can see R prime, this R prime, this is it, then this R, this is it, plus 2 molecules of carbon 4 oxide. All this happens at the anode, while at the cathode, you have a potassium hydroxide. Then the next method is hydrogenation of a unsaturated hydrocarbon. In hydrogenation, you add hydrogen to the unsaturated points. So you can see it's a carbon to carbon, there is double bond. So when you introduce hydrogen, the hydrogen will saturate this molecule. So there will be an alkane from alkane. So this method can also be used in preparation of alkane from alkyne, where you have triple bond. The only difference is that it's 2 molecules of hydrogen in these 2 molecules of hydrogen. And then we have reduction of alkyl halides. Alkyl halides are Rx, okay, where R is an alkyl group and X is a halogen. So in the presence of producing agents like lithium aluminum hydride, like sodium borohydride, like sodium cyanoborohydride, all of them will convert your alkyl halide to alkane, where the X of halogen is now replaced with a hydrogen. The number 5th method is decomposition of Grignard reagent. Grignard reagent, this is what is called Grignard reagent. Grignard reagent is ordinarily known as alkyl magnesium halide. So if you react alkyl magnesium halide with alkyl halide in the presence of acid and water molecule, you are definitely going to have an alkane. Then the last but not the least is the decarboxylation of carboxylic acid. So when you react carboxylic acid with sodium hydroxide, you end up having alkane and sodium carbonate. Now, we have mentioned 6 various ways of preparing alkanes from various reactants. Let us take a few examples of some of the methods we have mentioned. And the first one was Wurtz reaction. And you remember I told you that in Wurtz reaction, you have 2 molecules of alkyl halides reacting with 2 molecules of metallic sodium. So you can see here Rx, which is an alkyl halide, with 2 molecules of sodium, another Rx. In the presence of pure and dry ether, we are going to have RR plus 2 molecules of sodium halide. Now, how does this thing translate to normal organic reaction? We can see what we have this is a chloromethane, and then this is another chloromethane. Both of them are a group here, which is methyl. You can see the halogen, which is this. So this chloride, and take this chloride, and then there will be formation of a bond between this carbon and this carbon, and that is exactly what you have here. So when you have 2 molecules of methyl chloromethane, 2 molecules of chloromethane, you end up getting ethane. Why? The alkyl group is usually doubled. So if you have 1 carbon alkyl group in so if you have 2 molecules of this afterwards reaction, going to have 1 molecule of ethane. Look at the methyl group. You have CH3 here. You have 1, 2. How many sodium? Okay, so as I was saying, you can see 2 molecules of this giving rise to this. So if you count the number of carbon atoms here, you see you have 6. Then you also have 6 in the product, 2 sodium, 2 sodium, 2 chloride, 2 chloride. Again, this is a Walls reaction. However, if you observe what you have here and what you have here, you will see that here you have R and R, while in this place you have R and R prime. With this R prime here, with this prime of products. So when you carry outwards reaction using 2 different alkyl halides, you are going to have at least 3 different products. When you carry outwards reaction using 2 different alkyl halides, network is coming up. And so as I was saying, when you use different alkyl group, when you use different alkyl halide, we are going to have mixtures of products. The first product that will be formed is this and this to give R and R prime. The second product is R prime or R on its own, that is RR. The third product is R prime, R prime. So you can see the products we have here. You can see the first product is R prime, R prime. It doesn't matter the order of arrangement. That order of arrangement is not easy material. So you can see R prime, mixtures of products you are going to have if you use 2 different alkyl halides to run Walls reaction. And then let's take a look at the typical example. Here is a chloromethane reacting with a sodium and then chloroethane, okay? 1 chloroethane. So in this product, we are going to have, when this chloromethane, or rather, the 2 methyl group will give us ethane. Then this ethyl group and the methyl group will come together to give us propane. And then the 2 molecules of this ethyl group will come together to give us butane. So you see there are 3 mixtures of products. And so the question now is, how do you separate these alkanes? Knowing well that they have very close points. As a matter of fact, in crude oil refining, the whole of this will most likely come together as one fraction. So you now see the limitation of Wall's reaction. The limitation of Wall's reaction is that you cannot carry out Wall's reaction with two different alkyl halides. If you must use Wall's reaction, then you must use the same symmetrical alkyl halide, not unsymmetrical. Then let us look at coal-based synthesis. In coal-based synthesis, two molecules of sodium salt of carboxylic acid, or it can also be potassium. It must not be sodium salt. It can as well be potassium salt. When hydrolyzed, where you will give one molecule of alkane and then two molecules of carbon 4 oxide, two molecules of sodium hydroxide, and hydrogen. So coal-based synthesis usually takes is more of an electrolytic process where the alkane is deposited at the cathode, and then the sodium hydroxide, which will be formed, is deposited at the anode. This reaction is only suitable for the preparation of symmetrical alkanes. That is, alkanes of the same type RR. And the reason is the same reason we have given with Wall's reaction. Sabatier-Sanderin's reaction. In Sabatier-Sanderin's reaction is simple. This reaction is simply hydrogenation of alkene or alkyne to give an alkane. Okay? Sabatier-Sanderin reaction. Just the hydrogenation of alkene to give an alkane, or hydrogenation of alkyne to first of all give an alkene, which on further hydrogenation will give us an alkane. So you see here, this is a typical alkene with carbon-to-carbon double bond, and then this is hydrogen in the presence of either nickel, palladium, or platinum. Any of these metal can catalyze the hydrogenation of alkene to an alkane. You can see the extended hydrogen. These hydrogens are the new hydrogen coming from this. The other ones you can see, they are still there as H2H2. And so you know that this is an alkane while this is an alkene. And the same thing goes for alkyne here. This is carbon-to-carbon triple bond, undergoing the same process using either nickel, palladium, or platinum catalyst. The first thing that happens is that one molecule of hydrogen hydrogenates an alkyne to alkene. And that is why, pay attention. By the time we'll be discussing the synthesis of alkene, you are going to see that hydrogenation of alkyne is one way of preparing alkene. Then, by the time we look at the reactions of alkyne, you will also see that hydrogenation of alkyne will give alkene. So you see this alkene, which undergoes further hydrogenation in the same, using the same reaction condition to give an alkane. Unsaturated hydrocarbons going through nickel, palladium, or platinum in the presence of hydrogen to give saturated hydrocarbon. That is simply Sabatier-Sanderin's reaction. Preparation of cycloalkane. When 1,5-dihalogen alkanes are treated with zinc or sodium metal, it encourages condensation. So you see this Br here and this Br will join either the zinc or sodium. If it is sodium, then they are going to have two molecules of sodium bromide. If it's zinc, because zinc is divalent, you are just going to have zinc bromide. And then this is now cyclization, that is closing of the ring. It is no longer an open chain compound, it's now a cyclic compound. There is now a bond between this carbon and this carbon. That is the same carbon and this carbon after losing this Br and this Br. So from 1,5-dibromopentane, we can get cyclopentane using either sodium or zinc. Then another way of preparing a cyclic alkanes is by reaction of calcium or barium salt of a dicarboxylic acid in distilled. When it is distilled, a cyclic ketone is formed. So distillation here is simply heating. So when you heat this, there will be loss of CO2, carbon 4 oxide, and then barium oxide or barium carbonate. Barium carbonate. So the formation of barium carbonate, aids the formation of cyclopentanone. This is cyclopentanone. And cyclopentanone will undergo what is called Clemenson's reduction. Clemenson's reduction. Clemenson's reduction is simply the reaction of your cyclopentanone with zinc in mercury in the presence of HCl. So this reducing agent takes away oxygen. You remember that the reduction will be removal of oxygen, addition of hydrogen. So after reducing cyclopentanone, you get cyclopentane. Reactions of alkanes. Having considered the other part, which is the preparation of alkanes, it is now time to look at the reactions of alkanes. Number one, and the most prominent reactions of alkane, is halogenation. Halogenation. Alkanes react with halogen. You can see that's number one here. Alkanes react with halogens in the presence of photons or heat. Either photon or heat, UV light or heat. Any of these will help the reaction between alkane and halogen to give an alkyl halide. You can see alkyl halide Rx plus HX. That's the product from halogenation of alkane. The next reaction is nitration. In every nitration, you are introducing a nitro group. What is called a nitro group is simply NO2. NO2 is what is called nitro group. So in nitration reaction, alkanes nitric acid, that is tetranitrate 5. So it reacts with trioxonitrate 5. This is nitroalkane. Then the next reaction is isomerization. Isomerization is simply the conversion of one alkane from one or with one facilitation. We made mention of isomerization of both alkenes, and the rest. So in isomerization reaction, what is used is this Lewis acid, aluminum trichloride in HCl. So aluminum trichloride in HCl will convert the isomerization of butane, for instance, to 2-methyl propane. If you count the number of carbon, you see that they are the same molecule, but isomers. You have 1, 2, 3, 4 carbons. Let's count this one. 1, 2, 3, 4 carbons. Let's count the hydrogen. We have 3 here plus 2, 5, 7, 10. We have 3 here plus 3, 9. Sorry, 3 plus 3, 6, plus 1, 7, plus 3 here, 10. So you can see that both of them are isomers. Then the next reaction of alkane is aromatization. Alkanes like hexane, in the presence of chromium trioxide, This is a chromium trioxide. This is chromium trioxide in the presence of aluminum trioxide at a very high temperature of 775 Kelvin. It must not always be 775. It simply shows that there will be requirement of high temperature for this aromatization to take place. So the first thing that happens is that this compound is cyclized. Remember here, it is a straight chain compound. So the first thing that happens is the cyclization, and then after the cyclization follows the aromatization. Then we have the fifth reaction is pyrolysis. Pyrolysis simply implies the heating of a molecule generally. Okay, one can say a carbon molecule in the absence of oxygen. Okay, in the absence of oxygen. So even what you have as the essence is to break down the chain. Okay, when you pyrolyze a molecule, you move a large molecule to smaller molecule. And this is simply called cracking. In the case of petroleum refining, pyrolysis is called cracking. So remember, there is catalytic cracking, there is also thermal cracking. So you can either use heat or you can as well use a catalyst. The same thing happens. You have pyrolysis using temperature, and also you have pyrolysis using a catalyst. Then the sixth reaction of alkane is combustion. No matter the chain length of alkane they are heated in the presence of oxygen to give carbon 4 oxide, water molecule, and then energy will be given off. So this is a simple example of halogenation of alkane. You can see this is chloromethane undergoing further halogenation to get dichloromethane. Dichloromethane undergoing further halogenation to get trichloromethane. Trichloromethane undergoing further halogenation to get tetrachloromethane. Generally, halogenation of alkane takes place in 3 steps. The first step is called the initiation step. Okay, and these 3 steps are generally called free radical mechanism. So the mechanism of halogenation of alkane is known as free radical mechanism. And the first step of free radical mechanism is initiation. In initiation, the halogen reacting with either a UV light or heat will generate 2 molecules of radical. You can see the dots here, which shows is a radical. And you remember, radicals are very reactive species. Why is radical necessary? It is necessary because, okay, Owoicho, Wilson, please, what is the problem? Wilson, you raised up your hand. Can we take your concern? Hello, Wilson. Wilson, you raised up your hand. Can you unmute yourself and tell us what is the problem? Wilson, you aren't doing that. If you're having network problem, you can use the chat. Use the chat section and then tell us why you are raising up your hand. When we get that information, we will attend to it. Okay, so as I was saying, this halogenation takes place in 3 steps, generally called. Okay, Wilson, are you there?
Yes, sir.
Oh,
hello, sir.
Gladys. Are you speaking for Wilson or at the same time?
Oh my God. Hello.
Let them just continue.
Sir, continue.
Person.
Continue, sir.
Gladys.
Continue.
Hello, Gladys. Okay. Okay. So as I was saying, the reaction takes place where the free radical is generated by the reaction of chlorine or any other halogen with light or heat. Okay, the free radical will be generated. Then secondly, this free radical that is generated will now react with your alkane. The alkane free radical, you can see this, and this HCl. So this one now, you can see this is a free radical reacting with another chlorine molecule will now generate chloromethane and a free radical. So this step is called propagation. It is called propagation because at every point in this step, there will be generation of a free radical. You can see here, there was a free radical generated by the reaction of this first free radical with methane to get HCl and then this methyl radical. Then you can see here the methyl radical reacts and another chloride radical or step. Two free radicals react together to get a stable molecule. So in termination on the product side, you will not see anything called free radical. You take a look at what we have here. Two molecules of Cl radical reacted together to give Cl2. You can see at this point of the product, there is nothing like a free radical. So once two radicals come together, that is called termination step. And then once it is generation of free radical alone.
Okay.
Wilson. Adakole Wilson.
Hello, sir.
Yes, Wilson.
Sir, afternoon, sir. Sir, please, can I ask a question? Okay, the network.
Why not? Ask your question, please.
Okay. I don't know whether I can be able to watch exactly what you are saying, direct your writing. Hello.
Whether you can watch.
I don't know whether I can look at the whiteboard that you are writing anything on it for me to know the subheadings of the course unit that I am in.
Whether you can watch what, please. The subheading of the course. Yeah? Please,
Hello,
can
sir.
you use the chat option and tell me what the problem is? I don't know, maybe your network is breaking. Type your question using the chat option. Let me know exactly what you want.
Sir, can I see your your whiteboard?
I am not using whiteboard here. What we are on PowerPoint, not whiteboard.
Okay. Okay.
It's PowerPoint, not whiteboard.
Okay. So
That's a question now.
Go on.
Okay, sir. Can I view your PowerPoint?
Are you not seeing the PowerPoint there?
No, sir.
Why?
That is why I'm raising concern.
No, you are supposed to be seeing it now. It's already shared, and once you share your screen, whatever is on my computer, you are supposed to be seeing it.
Okay, let me see. Try it because I'm not seeing anything here.
See what you can do. Log
Okay,
out and log in again.
Okay, sir.
Let's see if that can solve your problem, please.
Okay, thank you, sir.
Aisha.
Janim, any problem? Okay, so as I was saying, at the termination stage, two of the radicals react together. You can see there are two molecules of chloride radical here. There is one chloride radical and one methyl radical here. And there are two molecules of methyl radical, giving us stable molecules. These are at the termination stage. Then nitration of alkane, just like halogenation, nitration of alkane follows the same free radical mechanism. You can see this is our HNO3, nitric acid. This is nitric acid at high temperature or vapor phase. You can see how it is now broken into NO2 radical and OH radical. And then the alkane as well, you can see CH bond being broken to R radical and then H radical. And then two molecules of the radical comes together to give water molecule, that is this and this, while the R radical comes together with the nitro radical to get nitroalkane. Now, the question is, why are most of the reactions we are seeing free radical? They are free radical because naturally, alkanes are not reactive. In alkanes, you don't have functional groups except the covalent bond. And these covalent bonds are very strong. And because these covalent bonds are very strong, it will require much energy to break a covalent bond. And that is why most of the reactions of alkane are passing through free radical mechanism. Isomerization of alkane. In isomerization, like I already told you, this is a butane in the presence of aluminum trichloride and hydrogen chloride gas. And then this will give you 2-methyl propane, which is an isomer of butane. Then this is this molecule is hexane. This is hexane. In the presence of the same aluminum trichloride and HCl, it will give us mass of hexane, which includes 1, 2, 3, 4, 5, 6, 2. There are here. If you discuss in then I will expect you to check the remaining isomer hexane with a hydrous aluminum trichloride. Aromatization of alkanes. 6 carbon open alkane and more with chromium 2 chromium trioxide or vanadium pentaoxide or molybdenum pentaoxide at very high temperature of 770. That is it must not always be 770. It can even go below a little or even a little above. But what happens, the first thing that happens is cyclization. Cyclization is the closing to a ring system. And then dehydrogenation, hydrogen. And this dehydrogenation gives rise to aromatization. You can see what we have here. This is normal hexane being reacted with any of these to give benzene. This is the same normal hexane. This is this and this are the same reagent, but I decided to show you more reagents so that we don't restrict yourself to just one reagent. So you can see that giving benzene, and then this is heptane. Heptane is 7 molecule, 7 carbon, and will now give you toluene. Pyrolysis of alkane. In pyrolysis, there is decomposition of organic substance by heating it to I have said that before. And this is well used in petroleum refining. So what happens is that when you heat or when you use a catalyst, you break chain compound to smooth compounds. So high boiling fractions of petroleum are converted into low boiling gasoline by cracking. And cracking is a form of pyrolysis. So you see what happens here. This is a hexane, okay? At 773 Kelvin, it will give one of the products is hexene. When an alkane, this is an alkane product here is butene, which is also an alkene. And then this one is ethane, which is an alkane. The other product is propene. It's in and then methane. Of products that is one hexane by the use of pyrolysis. Combustion of alkane. We have a complete combustion and incomplete combustion. Complete combustion means that there are excess of oxygen, and therefore, in the presence of excess oxygen, your alkane
Mungkin tapana na even na tapana na no just show vlog or. Hey, you okay?
Hello, Adekule. Can you hear me?
Yes, sir.
So, I think network is the facilitation since network is for. So can you like try to hold on for me?
You. Hello.
Yes, I can hear you. You're talking back. Anything. But to get up, I can make fast. Take it first. Then I will make it first. Take it first. Then the side. They're not the
What is going on, please?
I think there's no service, so maybe everybody should call it a day. I think that's necessary because it's almost 5.
Yeah. But you're supposed to tell us what is going on. If it's the network that's not connecting, you're supposed to correct.
Yes, he just left like that. That's not good.
So it's not his fault. We all know how to do something. So
well, we are speaking with each other now. We are speaking with each other now that the network is nice.
Yes, he may be trying to reach us. Maybe he's in his place.
Now. Yes.
Let's see wait a bit to know what you have in mind.
It's obvious. The meeting will just only 1 minute.
Yes, just only 1 minute.
Now your access back, we'll go pay money now.
Right. This bank, they displays money now.
They don't finish me.
Hey, don't finish. Are you the teacher?
What will be the number for the bet? Don't forget.
People are not serious.
988.
Okay.
978.
No mistake.
Why they scratching of the eye?
978.
So there, that should be 10,000. 10,000. Logo. Sure, you want from the our market.
The money na 98.
Okay. How come now leave this momo? We don't buy it. This was more. We don't buy it. You say no get money.
I don't
Which kind
follow
no get
up.
money? Which kind no get money?
The
No,
money
that
na
one, you
98,000.
you are not to carry money. Go give outside now. We dey here. We dey inside. They carry money. Go put them for outside. So this kind one no be like. You say say we even though you try for us, but now we don't go follow anybody party because now you will know before anybody. We go now God everything at time, but this time around we go try. We don't come back.
You see, I like where they disturb business.
Okay, it's network.
Better is network.
Yes. I better make I do
The money na
115. 156. Hey, not do myself for you.
Your money na
Read the paper.
Everyone.
98,800.
Hello. Can we continue?
Hey,
Yes, sir. Yes, sir.
Hello, can we continue?
Yes, sir.
Yes, sir, we can continue, sir.
right answer. But reduce the speed.
Okay. So, there was network challenge. Can you hear me now?
Yes, sir. Thank you, sir.
Okay. So please, we're about completing our assignment when we had this challenge. So I was already addressing the fact that complete combustion of alkane will give carbon 4 oxide and water molecule. And when we say complete combustion, we're indirectly talking of where there is excess of oxygen. Then incomplete combustion means there is carbon 2 oxide or carbon monoxide or only carbon. So the major difference between combustion and pyrolysis is that in pyrolysis, there is no oxygen. Okay, while in combustion, there is oxygen. Both of them involves heating, but while in pyrolysis, it is done in the absence of oxygen. In combustion, combustion takes place only in the presence of oxygen. So reaction of small ring compounds. We want to look at small cycloalkanes. They have just few of their reactions. The number one here is the cyclopropane. You know, propane is 3 carbon atoms. Cyclopropane means 1, 2, 3. They are a ring system. So if cyclopropane is hydrogenated in the presence of nickel and at 355 Kelvin, you propane. So both of them are still propane, both are still propane, but the difference is that while this is cyclopropane, this is a straight chain propane. So if you carry out bromination instead of hydrogenation, you are still going to get a cyclic compound where the bromo group attaches at the two carbon where there is a cleavage. Remember the hydrogen, this hydrogen here, one attached at this carbon, and then the second one attached at the second carbon here. Likewise, in bromination, one will attach at this carbon, and then the second one will attach at this other carbon. To give 1,3-dibromopropane. Then, if we carry out, one hydrogen will attach at this point, and then the bromine or another halogen will attach here. Importantly, what we have said is that whether it is hydrogenation, bromination, or hydrobromination, what it leads to is the breakage of the cyclic system. It leads the compound to move from cyclic to acyclic. And then whether you are adding hydrogen in this case, or you are adding bromine in this case, or you are adding hydrogen bromide in this case, you are going to get compounds that are no longer in ring, where the additional groups are now attached at the terminals at the end. So here at the end, you had hydrogen and hydrogen because we were bringing in two hydrogen. Here you had bromine and bromine because we were bringing in two bromine. Here you had bromine and hydrogen because we were bringing in hydrogen bromide. If the reagent now moves from any of these to conc H2SO4, you are definitely going to get a propanol or an alcohol. This name here is wrong. This is the name for this. Why this is the name for this? There was an interchange of name. This propanol here is for this, while this propane here is for this. So when you use conc H2SO4, which is normal hydrolysis, you end up getting an alcohol. Now, that brings me to one thing which I want you to take note of. Cyclic alkanes, it has similar behavior with alkene. They undergo addition reaction. Of course, you can see this is simple addition reaction. This is addition reaction. This is addition reaction. Even this is addition reaction. However, non-cycloalkanes don't undergo addition reaction. And that is why those ones undergo their reaction using free radical mechanism. So this is just butane. We expect that it is going to give the same kind of product, just that instead of 3 carbon here, we are now going to have 4 carbon. So if we bring in bromine in tetrachloromethane, we are still going to have 1,4-dibromobutane. If we bring in hydrogen in bromine, hydrogen bromide, we are still going to have 1-bromobutane. If we bring in conc H2SO4 and H2O to this compound, we are still going to have butane 1-ol. Questions and answers. So far what we have done is to look at methods of preparation of alkanes, both the cyclic and cyclic alkanes, and then also look at the reactions of alkanes, both the cyclic and acyclic alkanes. Let me take your question. Let me take your questions. Ogundeji, Wole, Ogundeji, Ogundeji, can we hear from you? Do you have any question?
Hello, sir. Can you hear me now, sir? Hello, sir.
Yes, I can hear you. Go on.
Yes, sir. We really thank you for the lecture, even though the network was frustrating. But the little one that we heard from you is very clear and sound. So thank you very much, sir.
Okay. Any question?
Yes, sir.
Okay.
I have question, sir.
Okay, go on.
You said, sir, you said the difference between combustion alkane and the cyclic cyclic and uncyclic alkane. I didn't understand. Okay, and pyrolysis.
I said difference between combustion and pyrolysis. In pyrolysis, if you are still heating your alkane.
That what is the yeah?
You are still heating your alkane, but in the absence of oxygen. That is pyrolysis. Pyrolysis goes on in the absence of oxygen. And that is why you cannot have shorter alkanes or alkenes, as the case may be. However, in combustion, combustion takes place in the presence of oxygen. And that is why it's going to be converted to oxides, either carbon oxide if you have excess, or carbon monoxide if you don't have enough oxygen. So the basic difference is, number one is the reaction condition. One takes place in the presence of oxygen, the other one takes place in the absence of oxygen, and then the products are also different.
Okay, sir.
Are you okay?
I understand, sir. Yes, sir. Thank you very much, sir.
Okay.
Yes, sir.
Salma Abubakar. Salma Abubakar.
Yes, I'm with you, sir. Sir, I joined the class.
Yes. Any question?
I will go through it. But I say I will go through the video again. In the next class, I'll bring up my questions, sir.
Okay. Okay, it's okay. Else. Wisdom. Wisdom, do you have any question? Hello, Wisdom. Wisdom, do you have any question? Wisdom is not there. I want to confirm something from you guys. I sent the PowerPoint for this class yesterday. Did you get any mail to that effect?
Power.
No, sir.
No, sir.
Is it possible the email address on the course page is not correct or what?
I always got your message.
Huh?
I always got your message, oh. But yesterday I didn't see any message. Yes.
Okay, it's okay. I'll resend it today.
Okay, sir.
Okay.
I'll resend it today.
Okay, sir.
Okay.
Thank you very much, sir.
Any other question?
So it's based on that.
All right, so see you next week. Enjoy your week. You said what? Grace.
Okay, thank you very much, sir. Sir, I said it's based on that email. I haven't gotten any of your questions, any of your information.
Come again.
Sir, I said it's the email. I have not gotten any of your message.
Okay. I'll drop my email address right now, so you can just send me a mail. I'll forward every other thing to you.
Okay, sir. Thank you very much, sir.
I'm dropping it right away.
Okay, sir.
Just wait for it.
Yeah, I'm waiting, sir.
Have you seen it?
Yes, sir.
So anybody can send me a mail using that email address for whatever we'll be able to interact to.
Okay, sir. Thank you,
All
sir.
right.
Yes, sir.
You are welcome. Okay.
Yeah, have a wonderful hour.
And you.
Thank you, sir.
Ogundeji.
Yes, sir.
Can you leave? I think when I was having network problem, it transferred the host to you. So nobody, just leave first so that we can shut down the meeting.
Okay, sir.
It's all right.